Welcome everybody to Numeracy for Engineering. In this particular resource, we're going to be looking at helping your learners develop an understanding of pi. And we also recommend that this resource be viewed with developing a vocabulary of circles and developing an understanding of the area of circles. The intention of this resource is to develop the learner's understanding of how the ratio pi can be used to calculate the circumference, diameter, or radius. And we're just going to look at some good, interesting ways to help your learners understand this rather than just having to remember the formula. First of all, you ask learners to have a discussion about where pi is useful and why pi is useful and what it's going to be used for in their context. The second thing is you're going to hand out a sheet. It's going to look like this, and in groups learners can work together and measure a range of objects. And what they're going to do is they're going to write down the name of the object. They're going to measure the circumference of the object and the diameter, and they're going to work out what the ratio between those two is and explore them. And so what they're going to need is a measuring tape, some string, and a whole lot of different things that they can measure: tin cups, pots and pans, rubbish bins, whatever you can find that's circular and in different sizes. Here we go. So the idea is you hand out for your learners a sheet of paper like this. It has a column for objects, in this case a tin cup. But ideally you'd want your learners to have 5 or 6 different objects that they could explore this with as well and fill into the form. Using a piece of string, which is often easiest, you can just measure approximation, and why it only needs to be an approximation is going to become clear soon. And just getting the learners to then measure that string against the measuring tape. And there you can see that it's 315 millimeters. And then having the learners write it in 315 millimeters. And then moving on to the other two columns, diameter and radius. You can get the learners to use the measuring tape. Sometimes that's easier. And then just measuring the string against the measuring tape again. And that's 100 millimeters, which is actually pretty good. That is going to put us pretty close to the actual measurement of pi. So just writing that in, and we know that the radius is half of that, so sometimes it's easier just to divide it by 2. A quick calculation: 315 divided by 100, 3.15. Your learners might do that with a calculator, but we can do it in our heads. So your learners will have been using a sheet like this to measure lots of different types of circles and also their diameter and radius, and then dividing the circumference by the diameter to get a number. Now by the end of this activity, your learners will have a sheet that looks something like this. They will have measured, for example, a tin cup, which is a small object, a trough, that's a much larger object, plastic pipe, rubbish bin, and they will have begun to see that the circumference divided by the diameter is beginning to be very much the same. And even though right now it's not exactly the 3.141 that we want, it's just an approximation, this is okay, because in the next activity we're going to tidy this up. Now the way I've done it, and the way it's also recommended in the measurement book, is to put a measuring tape on the whiteboard, measuring from 2 to 4 in this case. It doesn't have to be, but that's sometimes easier. I've actually printed this out sometimes in larger numbers to make this activity easier. So we have this on the whiteboard, and then for example for the tin cup, we want group number 1 to come and put an arrow at what their ratio was between the circumference and the diameter. So I believe it was 3.15, but it's going to be somewhere between 3.1 and 3.2. And then the next group comes and puts in where theirs was, and so on and so on. And what will tend to happen, or what will definitely happen, is that the learners' answers, even though they weren't so accurate, will begin to cluster around a single point. And that single point will of course be pi. Now, what I've tended to do is I've had multiple measuring tapes, and I've asked each group to come and repeat this process with all of the different items that they've measured. So they get to see that the tin cup always equals somewhere between 3.14 and 3.2, or 3.1 and 3.2, sorry. And they also get to see that the trough outside, a really large circle, is also somewhere between 3.1 and 3.2. The ratio remains the same no matter how big the circle is. That is the learning point for this. Once this point is reached, you can begin to really talk about terms of accuracy in terms of pi, and how pi is an irrational number if you wanted to go there, how it can be calculated by dividing 355 by 113 if you wanted to go there. I often don't. 3.14 is often enough, but perhaps in the engineering context you want to go to a few more decimal places. Now would be the time to talk about this, but the difference is that the learners have begun to discover it by themselves. So rather than just trying to memorize that digit, they really have an understanding of what that digit means. Another useful thing I've used is that if you go to Google Images, there's things called GIFs. That's GIFS. And if you just put in pi, P-I, GIFs, what that will take you to is a moving picture that demonstrates something, and there's a whole lot of really great maths ones. And so again, if you just put in pi, Google Images, GIFs, you'll get some really good ones. And if you've got access to a PowerPoint or you can show the learners something on a screen, then what this does, it's just like a 3-second clip, and it just represents how pi is found. Very useful. I've found them very useful for a whole lot of things that I've done. So just to sum up and recap this particular session. Number one, first thing you want to do is ask the learners to discuss contexts in which finding the circumference is useful. We really want them to be able to talk about why it's useful and why they want to know it. Second thing is you have learners explore diameters and radius with different size circles. That is, you want them to go out and measure things and fill in that form, and there'll be a PDF for that form as well. And you want them to go out and become explorers in this. You want them then to identify the common ratio, and that is when you've got the measuring tape on the board and the learners are coming in, perhaps either sticking a post-it where they think it is or drawing an arrow next to it, and they're beginning to realize that all these different circles always have a common ratio between the circumference and the diameter. And finally, you want to discuss this and then apply it immediately. Get them working things out for themselves.